You'd think the scariest things in a desert are sandstorms and thirst, right? But for thousands of years, one river has been flowing across that scorching sand and it's never once dried up. Under normal circumstances, a desert should suck a river bone dry in a matter of days. And yet, the Nile flows for over 4,100 miles across the hottest land on Earth and just keeps on going. It's almost like nature secretly built in a few mechanisms just to keep this one river alive. If you love unraveling historical mysteries, hit subscribe and let's dive in. Today, as we trace these secrets one by one, we'll find that even this flawless design started unraveling after just 100 years of human intervention, and by the end, we'll come face to face with a threat that's almost invisible to the naked eye. So let's dig into exactly how this river never dries up. The Nile stretches an incredible 4,130 miles, making it the longest river on Earth, and most of that distance cuts through desert that doesn't see a single drop of rain. Logically, a river this long, flowing over scorching sand, should evaporate somewhere along the way. And yet, against all odds, the Nile carries its water all the way downstream. Here's something worth pointing out. We tend to think of the Nile as a single river, right? But that's not actually true. The Nile is really two rivers with completely different personalities merged into one. One is the White Nile, and the other is the Blue Nile. The way each one supplies water is completely different, and that difference is the first mechanism that keeps this river from ever running dry. Let's start with the White Nile. It begins way down near the equator, fed by Africa's Great Lakes. Massive lakes like Lake Victoria serve as its source, and this water moves at a crawl. But in exchange, it flows steadily, year-round, without interruption. Rain or no rain, it doesn't matter. It's basically like having a giant water tank constantly pushing water through from behind. So during the dry season, the White Nile is responsible for 70 to 90% of the Nile's total flow. It quietly carries the river through the exact stretch when it should be running dry. Now let's look at the Blue Nile. It flows down from the Ethiopian highlands, and its personality is a total 180 from the White Nile. It's calm most of the year until summer hits and it completely transforms. When the summer monsoon rains pour down over the Ethiopian highlands, the Blue Nile suddenly explodes in volume. During this period, the Blue Nile alone contributes 80 to 86% of the Nile's water. Meanwhile, the White Nile, the one that carried the load during the dry season, drops below 30%. The lead role completely switches hands for the summer. Now, if you overlay the two, the full picture comes into focus. The White Nile protects the river when there's no rain. The Blue Nile fills it back up when the rain pours down. Their downtime never overlaps. It's perfectly staggered. Put simply, it's like the river has two hearts keeping its heart beating. While one heart takes a brief rest, the other picks up the slack right on cue. That's why the Nile never skips a beat, not for a single moment, all 12 months of the year. Two hearts, splitting the seasons between them, are what keep this river alive. Here's another interesting fact. About 90% of what we know as Nile water actually comes from the Ethiopian highlands. And when it comes to the mud, the sediment the river carries, a full 96% originates from that same region. Keep that mud in mind. It's going to come back in a big way later. But before these two rivers merge into one, there's a stretch where the water seems to vanish entirely. Water clearly flows in, but only half of it comes out the other side. On a map, it genuinely looks like the river just evaporates into thin air. So where does the other half go? If you follow the White Nile south, you enter South Sudan, and this is where the river starts acting strange. Instead of flowing as one clean channel, it splinters in every direction and seeps into an endless sea of reeds. This massive wetland is called the Sudd, Arabic for obstacle. Even its name is a warning. This is a wall built to stop people. Let me put its size into perspective. Even during the dry season, the core wetland covers over 3,200 square miles. But once the rainy season hits, it can swell to as much as 50,000 square miles. That's an area roughly the size of the entire state of New York, or all of England submerged underwater. When a single river scatters into a swamp this massive, satellite imagery makes it look like the river has genuinely disappeared. What was once a clear, defined channel spreads out into a blur of reeds until you can no longer tell where the river ends and the swamp begins. In fact, the waterways here shift so unpredictably from season to season that maps of the area used to become useless within just a few years. But here's what's really surprising. More than half of the water that flows into this swamp, somewhere between 50 and 55%, simply evaporates straight into the sky. On the surface, that sounds like a total disaster for the river. It's essentially losing half of all that hard-won water in the middle of the desert. And yet, the seemingly wasteful swamp turns out to be the river's second survival mechanism. The Sudd handles water in a truly unusual way. During the rainy season, when water is overflowing, the reed beds soak it all up like a giant sponge. Then, when the dry season comes and water runs short, it slowly releases what it's been holding back downstream. In short, it's a giant natural sponge, soaked up one season, wrung out the next. Thanks to this buffering effect, the water flowing downstream never suddenly floods or abruptly cuts off. It stays remarkably steady all year round. So, what would have happened without this swamp? The monsoon downpours would have slammed straight into the lands downstream, and then the river would have run dry the instant the dry season hit. Losing half to evaporation looks like a loss, but it's actually a worthwhile trade, delivering the remaining half downstream in the most stable form possible. And here's the really fascinating part. The Sudd didn't just block water. For nearly 2,000 years, it blocked people too. Back in 61 AD, the Roman Emperor Nero sent an expedition to find the source of the Nile. Led by 2 centurions, the expedition made its way upstream until the Sudd stopped them cold. Faced with endless reeds and mud, they simply couldn't find a way through. Beneath their feet was neither solid ground nor open water, just swamp, and ahead of them, nothing but reeds towering well over their heads. In the end, they turned back without ever laying eyes on the Nile's true source. About 1,800 years later, in 1839, the exact same thing happened again. Muhammad Ali, Egypt's de facto ruler at the time, launched a large fleet to locate the source of the Nile. But the moment these ships entered the Sudd, they too got stuck fast in the green swamp. Commander Salim Bimbashi's fleet was trapped in the swamp for nearly a month before finally being forced to turn back. From Roman soldiers to a 19th century fleet, no era was spared. They all met their match at the same green swamp. It's a strange irony. The very swamp that kept the river alive was also the swamp that swallowed human ambition again and again. But the swamp wasn't the only reason this river survived. Buried beneath the desert was another clue we didn't know about until now. And something even more astonishing than the secret of this wetland was buried deep beneath the scorching desert floor. In 1981, the Space Shuttle Columbia was passing over the Sahara. On board was a specialized radar instrument called SIR-1. Unlike our eyes, this radar could actually see through dry sand and peer beneath the surface. When scientists reviewed the images it captured, they were stunned. Beneath what looked like empty desert, the traces of an enormous ancient river system emerged. This was a channel measuring anywhere from roughly 5 to 12 miles across. Today, it's completely buried under sand, a river that appears on no map. People started calling them the radar rivers. And here's the truly remarkable part. Those ghost rivers belong to an incredibly distant geological era. They're believed to date back to the mid-Cenozoic era, millions of years ago. Beneath what's now the driest land on Earth, rivers that once flowed powerfully lie sleeping like fossils. To be clear, those radar rivers belong to an incredibly distant geological era. But there's another chapter to this story, from an entirely different time period. During what's known as the last interglacial period, somewhere between 130,000 and 100,000 years ago, the Sahara wasn't a desert at all. It was a lush, green savanna, fed by plentiful rainfall. Across this grassland, several major rivers likely ran north to south through the Sahara. What's fascinating is that these waterways may have served as migration corridors for humans leaving Africa and spreading across the world. It's possible our ancestors once walked alongside the rivers of a green Sahara. It's a striking thought. The same land where even camels struggle today may have once been a thoroughfare teeming with life. So, doesn't this raise an obvious question? With all those other rivers gone, why did the Nile alone manage to survive? This is where the final survival mechanism comes in, and the answer lies in the shape of the land itself. Long ago, the Ethiopian highlands slowly rose upward through volcanic activity and tectonic uplift. As the land climbed higher, the Blue Nile began carving its way down a steep incline. Over countless centuries, that fast-moving current cut deep into the earth. The result is the deep Blue Nile Gorge, a place often compared to America's own Grand Canyon. And this gorge became a kind of shield for the river. Here's the simple version. The desert's scorching wind sweeps across a water's surface and evaporates it. But when a river flows hidden at the bottom of a deep gorge, the surface area exposed to that wind shrinks dramatically. Even as scorching wind sweeps across the top of the gorge, the river far below stays protected in the shade. While the ghost rivers sleeping beneath the desert were left fully exposed to the sun and dried up completely, the Nile alone survived by hiding away in a gorge that functioned like an underground bunker. Without this gorge, the Nile might have ended up just like those radar rivers, a fossil buried under sand. On a cosmic scale, this is a remarkably elegant twist of fate. A single geological event, land rising out of the earth, ended up protecting millions of years later the very river that would feed an entire civilization. So that's the three-layered survival system nature built for this river: a dual pump heart, a natural sponge wetland, and a gorge acting as a shield. But over just the last 100 years, something has quietly started tampering with this perfect balance. Our story jumps to 1970 when a massive concrete wall went up in southern Egypt. This was the Aswan High Dam, and its purpose was clear: stop the Nile's annual flooding and generate electricity. And it accomplished exactly that, brilliantly. Behind the dam, an enormous man-made reservoir called Lake Nasser was formed. It stretches nearly 310 miles in length alone. The floods disappeared, and electricity flowed reliably. To give you an idea of the sheer scale of this project, engineers relocated the entire Abu Simbel temple complex, which was at risk of being submerged. They cut it into a staggering 1,042 blocks, then hauled every piece up to higher ground and reassembled it exactly as it was. It felt like the moment human engineering had fully tamed a river. But here's where things take a turn. This dam didn't just stop the floods. Remember that dark mud we mentioned earlier? The nutrient rich sediment the river carried down from the Ethiopian highlands? All of it started sinking straight to the bottom of Lake Nasser. Before the dam, nearly 100 million tons of sediment flowed downstream every single year. That mud was essentially free fertilizer spread across the delta's farmland, a gift nature had been delivering for thousands of years, and one concrete wall cut off that delivery overnight. But the problem didn't stop there. The Nile Delta itself was originally built up entirely from that accumulated mud. As long as the river kept depositing sediment, the land kept slowly expanding. But once the supply was cut off, the whole process reversed. The delta stopped being land that grows and became land that erodes. At the mouth of the Rosetta Branch, the coastline is retreating by roughly 100 to 200 feet every single year. The sea is quite literally eating away at the land, bit by bit. And here's the twist. The mud isn't the only problem. Global warming is pushing sea levels up by more than zero point 0.1 inches every year. On top of that, the land itself is sinking due to subsidence. Combine the two, and the delta effectively sinks about zero point 0.4 inches deeper into the sea every year. 0.4 inches doesn't sound like much, right? But the delta is almost entirely flat land. So even the slightest sinking lets seawater push deep inland. And the consequences are unfolding quietly and terrifyingly. Salt from the sea is seeping into the groundwater, so wells are starting to pull up salty water. Both drinking water and irrigation water are turning brackish. White layers of salt are slowly building up across the fields, land that was once one of the world's greatest breadbaskets. And as that white salt spreads across the soil, more and more of this land is becoming unfarmable. The real problem is that this delta is Egypt's heart. Tens of millions of people are packed into this one narrow strip of land, and the vast majority of the water Egypt uses ultimately comes from this very river. So the delta slowly turning salty isn't just a story about land. It means the food and drinking water of an enormous number of people are on the line. Experts warn that by 2100, a significant portion of the delta could be underwater, potentially forcing as many as 4 million people to relocate. Let's zoom out for a second, because this isn't just a Nile story. The Colorado River in the US has lost around 20% of its flow since 2000. Iraq's Tigris and Euphrates rivers have lost more than half of theirs. In both cases, upstream dam construction and climate change combined to cause it. It's a clear signal that even the biggest, most resilient rivers can be destabilized when human intervention and climate change push together. And recently, there's been a major development upstream on the Blue Nile, too. This is the story of GERD, Ethiopia's massive new dam. Construction was completed in September 2025, and it's now fully operational. It's now the largest hydroelectric power plant on the entire African continent. That said, the countries along the Nile Basin are still negotiating the operating rules, specifically how much water to release during droughts. This isn't really about pointing fingers. When the lives of more than 200 million people depend on a single river, caution is simply unavoidable. In the end, it's a deeply human dilemma. The very technology meant to save lives ends up leaving behind costs no one saw coming. So, how does it feel having followed this whole story? The fact that the Nile crosses 4,130 miles of the hottest desert on Earth without ever drying up was never a coincidence. Two hearts splitting the seasons between them, the Sudd wetlands soaking up water and releasing it back, and a gorge shielding the river from scorching wind. This three-layered design by nature is what has kept this river alive for thousands of years. And yet, we managed to destabilize that intricate balance in just a century. Even right now, at the edge of the delta, land is slowly sinking beneath the sea. Turns out, it doesn't take nearly as long to unravel something nature spent thousands of years perfecting. Whether the Nile keeps flowing from here on out isn't really up to the river anymore. It's up to us. All those ghost rivers sleeping beneath the desert once flowed proudly across the map too, just like the Nile does now. And if the choices we make now keep piling up the wrong way, someday the Nile might end up sleeping right alongside them. When we look at Egypt, it's so easy to focus entirely on the pyramids and the ancient ruins, completely missing the one river that made all of it possible in the first place. The truth is, the answer isn't as simple as never touch nature or do whatever we want. It's about finding a fragile, necessary balance. After all, neither the Aswan Dam nor the recent GERD dam were ever built with the intention of ruining the river. This has been Olivia from Professor Room. Thanks for watching.